Hello everyone. Today we'll be going over a polynomial function that not only represents a linear and quadratic root, but as well as some real world situations such as roller coasters, a slope of a hill, and even inhaling and exhaling. Okay, let's begin. Here's our function fx equals negative parentheses x minus 4 parentheses x minus 3 parentheses with the exponent of 1 parentheses x parentheses with the exponent of 2. Okay, so we will graph that, and because we are switching up the signs, it's gonna be positive 3 and positive 4. But on the graph, we know that x is 0, 0, so we could put a dot on 0, 0, and then a positive 3, dot on positive 3, and then a dot on positive 4. Okay, and because the quadratic root, we start right here. Since there is no specific point on the negative axis, we're just gonna go across, straight line across the 0, and then we're gonna go down because it's a quadratic, straight to negative 3. We're gonna go a little way up and then straight down to positive 4, like so. Okay, and now we can see that our function degree is 4 because we have 4 degrees, 2, 1, and then this one right here. Total of 4, so it's going to be an even function because 4 is an even number. And because the graph is pointing down, it's going to be a negative. And to find the end behavior, just look at the arrows on the side they're pointing. So as x approaches negative infinity, f of x is going to be negative infinity. And as x approaches positive infinity, f of x is going to be negative infinity because it's going down instead of up. Okay, and we can put that our x-intercepts are 0, 0 because it's going across 0, and then 3, 0 because it's on 3, 0, and then 4, 0 because it's on 4, 0. And then our y-intercept would be just 0. And then for multiplicity, we can see that there is a linear root on 4. We could put x equals 4, and there's a linear root. And then we could see that there is a quadratic root on 0. So we can put x equals 0, and there is a quadratic root. And then we can see that there is also another linear root on 3 because it's going straight. We put 3, there is a linear root. And then we can find the increasing/decreasing intervals. So it's increasing all the way to 0. It decreases all the way to 4. It increases all the way up to 3. And then it decreases again all the way down. Okay, and then we can use this as a real world situation or examples for roller coasters and hills, because a roller coaster goes up and down. So just imagine this being a roller coaster. You're going up and you're also going down. Then you go up again and you go down again to the finish line. And same thing with the hill. You're driving, you're going up the hill, and then you go down the hill, and then you go up the hill again, and then you go down the hill. And the same thing with inhaling because you're breathing in, you're going up, and breathing down, you're going down. This concludes how to graph a polynomial function while explaining a real world situation such as roller coasters, slopes of hills, and even inhaling and exhaling.